Hey, why do I have a feeling I won't be able to reproduce these results? So this is the code that we currently have. We would like the model to make sure the model is actually saved, but yeah, we just like to improve it slightly. Otherwise, these settings seem to do something useful, even though the training is fluctuating quite a bit. I think we already explained it, but I don't fully understand why does that happen. But then the validation accuracy is quite high and loss is quite low. But the training is a bit weird. The number of epochs should be fine, but there might be other parameters.
It seems like your model is now showing some interesting results, though there are fluctuations in the training accuracy and loss curves, while the validation accuracy and loss remain more stable. Let me address each of the points you mentioned and suggest some next steps to further refine your model. Understanding the current results. Training fluctuations. The fluctuations in the training accuracy and loss curves could be due to several factors. One common cause is the use of a small batch size, 16 in your case, which can lead to high variance between batches, especially when the model is trained on a relatively small dataset. This high variance can cause the model to have drastic changes in accuracy and loss from one epoch to another. Another factor could be the learning rate. Although you are using a learning rate recommended by the study, it might still be too high for your specific dataset, causing the model to oscillate rather than converge smoothly. 2. Validation performance. The validation accuracy and loss show a much more stable trend, which is good. This stability indicates that your model is generalizing well to unseen data, which is often more important than having stable training curves. However, the discrepancy between the training and validation curves, particularly the fluctuations in the training data, might suggest overfitting to some batches or a model that hasn't yet fully converged. Consider reducing the learning rate slightly to see if it smooths out the training fluctuations. You can start with a reduction by a factor of 2, e.g. from 0.01 to 0.005, and observe the impact on the training process. 2. Experiment with batch size. Increasing the batch size might help reduce the variance between batches, leading to smoother training curves. You could try increasing it to 32 or 64, depending on your hardware constraints. Although you turned off data augmentation, it might be beneficial to experiment with it again, especially if your model starts to overfit as you reduce the fluctuations in training. Adding dropout layers in the model architecture could also help by providing regularization. 4. Learning rate schedules or optimizers. Implementing a learning rate schedule, e.g. learning rate decay or using a learning rate scheduler, can help the model converge more smoothly. Alternatively, experimenting with different optimizers like Atom, which adapts the learning rate during training, might yield better results. Since your model is starting to perform well after 15 epochs, you might want to extend the number of epochs to see if the performance improves further. Early stopping with a patience parameter will prevent unnecessary overtraining. Reproducibility. You've set the random seeds for NumPy and TensorFlow, which will help in reproducing your results. Regularization. Consider adding dropout layers after the fully connected layers to prevent overfitting. Given these points, your model seems to be on the right track, and with a few more tweaks, you could improve its stability and performance further. Keep iterating, and you should be able to refine your results even more.